In this video, we are going to learn how to make multiple representations of the same algebraic relationship. In doing so, we are going to talk about a new term, the term coefficient. The coefficient is the number that a variable is multiplied by. So if you had 3n, which we of course know means 3 times n, the n is the variable. The 3 is the coefficient. And then the whole thing, the 3n, is called a term. It is also the product because it is the answer when you multiply. So in algebra, when we talk about multiple representations, there are always 4. And the first one is the situation or the word problem. This is usually the one that you would be given, but sometimes you're asked to come up with it as well. In this problem, we're going to say that you have a car that gets 30 miles per gallon. So if you fill it up with 1 gallon of gas, you would be able to drive 30 miles. There's not much else we need to do for this. It's just important that we know that the situation is one of those representations. The second representation is a table. So I'm going to rewrite what the situation was. So we get 30 miles per gallon is our situation. And now we're going to make a table. So we know how to do this because we did this in our ratio unit, and we now know which variable to put first. So if we're doing 30 miles per gallon, then we're probably going to say that miles is the dependent variable because the number of miles you can drive depends on the number of gallons in your car. However, it's important to note here that depending on what the problem was asking for, you might do it the other way around, right? If I asked you how much gas would it take to drive 100 miles, then you would need to switch those because now the gallons is depending on the miles. But we're going to do it the first way. We're going to say gallons is independent. So that means I'm going to put gallons here in the first column and miles in the second. And then we'll fill out our table. So we know if we have 0 gallons, then we can drive 0 miles. If we have 1 gallon, then we could drive 30. If we have 2 gallons, we can drive 60. If we have 3 gallons, we can drive 90. And if we have 4 gallons, then we can drive 120 miles. And if we have 5 gallons, we can drive 150. This is that second representation, a table, which should be pretty familiar. Make sure that you've titled titled the columns of your table as gallons and miles. The next representation is a graph. So for the graph, we're going to graph that data from the table. We also know how to do this one. And now that we know that independent and dependent variables, we're going to make sure to put gallons on the x-axis and miles on the y-axis. We'll pick an appropriate scale for each axis, and then we will plot our points. And then we have to decide, should we connect the points or not? Can you use half a gallon of gas? Can you use 1/8 of a gallon of gas? Yeah, I think so. So I'm going to connect the points. And then we must give it a title. I'm going to call it gas mileage. Take a moment to double check your graph. Make sure your scale looks good. Make sure your points are neatly graphed. And then we'll move on to representation 4, which is the new one. So the final representation is writing an equation. So in order to have an equation, we need to start by identifying the variables. So those are the same variables that you would put on the x-axis and the y-axis. Those are your independent and dependent variables. So in this case, we have gallons of gas and miles. Now we also need to give them a letter. So if you don't have anything else, it makes sense to use a letter that's like the first letter of what your variable is. So we're going to say G is for gallons and M is miles. You can always use X and Y too if you're not sure what else to use. Next, we need to think about how those variables are related. And I always find that it helps to think of an example. So we know that the miles depends on the gallons that you have. For example, if you have 1 gallon, then you could drive 30 miles. Let's do another one. I know that if I have 3 gallons, I could drive 90 miles. We're trying to think about what's happening there. Well, it looks like we're taking the number of gallons and we are multiplying by 30 to get the number of miles. We're taking the number of gallons times 30 to get the number of miles. Finally, we're almost there, but we need to write that equation for the relationship. So since the number of gallons times 30 gives us the number of miles, then we could say that 30G, because that's what the coefficient means, right? That's the multiplying, equals M. And of course, we can always write it the other way around too, that the miles equals 30 times the number of gallons. So you can see that the fourth representation, the equation, it's definitely the shortest, but it can also be the trickiest to come up with. And it's also important to note that along with the equation, identifying the variables is a vital part of that when M is miles and G is gallons. You don't ever want to leave an equation by itself without your variables identified. Okay, for your practice problem, you're going to write an equation for this situation. The situation is there are 10 more boys than girls. It can sometimes help to make a table first if you're not sure what to do. There are 10 more boys than girls. Write an equation and be sure to identify your variables.